All right, this is the key concepts and cooldown from our first unit, which is Geometry Unit 8, actually, for illustrative mathematics. And what we're going to be talking about is using tables for conditional probability. So, here we've got a table of values, which is a really good, helpful way for us to organize information. And also, it's helpful in computing probabilities. So, let's take a look at this data. If a student is randomly selected from this group of students, we can actually find a number of probabilities based on the table. For example, the probability of grade 12 in going to prom. So that's a student randomly chosen, and the probability that they're in grade 12 and also going to prom. To find this particular probability, what we have to do is we have to find the number of students who are in grade 12 and going to prom, which is right here, and divide by the total. That's what we would call the joint frequency. Joint frequency, because we have two different criteria. It has to be grade 12 and going to prom. Now, the probability of just being in grade 12, well, how many students are in grade 12? 116. How many are there total? 243. How about the probability of just going to prom? Well, there's 124 going to prom out of 243 total. Now, the probability of grade 12 or going to prom. Grade 12 or going to prom. What we're going to do is we're going to look at all of the numbers in boxes for either grade 12 or going to prom. So it's these three boxes. And if we add those three together, we get, 124, 159 out of our total of 243. Now, if you recall, there is actually a rule for this too. The probability of grade 12 and prom would actually equal the probability of grade 12 plus the probability of prom minus the probability of grade 12 and going to prom. The reason for that is because if we add this number and this number together, what that is we're adding up all of these, and then we're adding up all of these, and if you look, 81 got counted twice. That and category got counted twice. So the probability of 12 or prom, again, would just be the probability of 12, grade 12, so that would be 124 out of 243, plus the probability of going to prom. I got that wrong. Probability of going to prom is 124 out of 243. If I add to that the probability of grade 12, that would be 116 out of 243. And then we would just take away the probability for this category, so that would be 81 out of 243. So that's your addition rule, figuring out the or part. Now, down here, this is where we start talking about conditional probability. This is when we have two things and we already know what one of them is. One of them's already been decided. So this is the probability of going to prom given that the student is a 12th grade student. So what we're going to do is we're going to have our total be the number of 12th grade students, which is 116. And then out of those 116 going to who are seniors, grade 12, there's 81 of them going to prom. Or for the second one, it's the probability of grade 11, given that they're going to prom. Well, again, my total in this case is going to be the total number going to prom, because we already know it's a student going to prom. So there are 43 out of those 124 that are going to prom, and that's how we come up with that. Now, there's another way we could do this. There's this rule called the multiplication rule, where if we want to know what the probability of A and B is, what's the probability of someone being in grade 12 and going to prom? Well, we could figure it out using this equation here, this formula. This is the probability of A given that B is true times the probability of B. Or you can actually rewrite that by dividing both sides by probability of B. And that's what you get over here. So if we take a look, the probability of going to prom, given that they're in grade 12, what we're going to do is we're going to say, so we're looking for the probability of going to prom given that they're in grade 12. We can use this formula. So the probability of going to prom and grade 12, we already saw, was 81 over 243. And then the probability that out of those 243 students who are going to prom, 116 of them are seniors. So that's this 116 out of 243. Now, to figure out where this 81 over 116 came from, we just have to keep in mind that this is a complex fraction. What we have to do is keep in mind that that's 81 over 243 divided by 116 over 243. And that's where the freeze, change, flip rule comes into play. We leave the first fraction alone, change that to a multiplication, and then we multiply by the other fraction flipped over. The 243's cancel, multiply straight across, and we get 81 out of 116. Let's take a look at the cool down. A large aquarium has 48 guppy fish in it. The table summarizes the fish based on color and sex. If a guppy is selected at random from the aquarium, what is the probability that it is blue and female? Well, how many blue females are there? What's the total number of fish? This doesn't include any totals, so you're going to have to do some very simple calculations. Number 2, if a guppy is selected at random from the aquarium, what's the probability that it's blue? Well, how many do we have that are blue? Okay, find the conditional probability that it's a female given that it's a blue fish. Well, we could use this formula that we came up with before. So the probability that it's female given that it's blue could be the probability of female and blue divided by, I can't remember. Probability of B. Okay. So the probability of female and blue is the same as the probability of female and blue divided by just the probability of blue. So that's one way to do it. You could also just ask yourself how many blue ones are there and then how many females are there. Bottom number, top number. I think that's about it. Sorry this one went a little longer than usual, but if you have any questions, let me know.